Good day, everyone. Today, our group will be discussing about how math is present in the arts and the humanities. Apart from the four corners of our classrooms, math is also prominently seen in our world. We can seek math from several aspects, from our daily routines to creative fields. For today, we will be exploring how math is evident in the arts and the humanities. To start, math is present in the arts and humanities when mathematical concepts are used artistically and when math plays a major role in the piece of art. Before we start, we wish to show a few examples of how math is integrated in the arts, specifically the visual and audiovisual arts. First, first here is the Dutch graphic artist MC Escher, who produced fascinating tessellations using irregular polygons. Next. Second, here is the animated film Flatland, which revolved around the concepts of line, plane, and 3D space. The characters assumed polygonal shapes whose extent of movement is constrained by their 2D world. Next, here is the Filipino national artist for visual arts, Vicente Manansala, who applied angles and other geometric principles in his transparent cubism style of painting. Math and art has a common ground, and that is the concept of patterns, symmetries, and geometric gestures. Our group will be further discussing how math is present in music, dance, rhythm, architecture, and poems, when mathematical concepts are used artistically, and when math plays a huge role in a piece of art.
Now we start off with the relationship of math and music by looking at arguably one of the most famous piano pieces of all time. Ludwig van Beethoven was a German music composer and is regarded as one of the most admired faces of Western classical music. His popular piano piece was Moonlight Sonata, although Beethoven himself referred to this piece as Piano Sonata number 14. The piece starts off with the initial part we call the first movement. The first movement contains a set of notes we call triplets. These four of these triplets compose the first musical bar counted as 1 and a, 2 and a, 3 and a, 4 and a. German poet Ludwig Rellstab analogized the notes on the first movement as the moonlight shining upon Lake Lucerne. We proceed with Leon Ndugu Chancellor. He was an American jazz, pop, and funk percussionist. Outside the music industry, he was a university producer. He said that once we start looking at how rhythm is developed, we realize the role of math plays in percussion. He discussed that a whole note has 4 beats, and succeedingly a quarter note has 1 beat, an eighth note has 1/2 of a beat, and a 16th note has 1/4 of a beat. Now at the composition of the notes, 4 quarter notes compose a whole note, 2/8 notes compose a quarter note, and 4/16 notes compose a compose eighth notes. So in these, we can see where they are heading, and if we go to the trend, we can realize that math is essential to music. Now, by analyzing the musical components and properties found in Beethoven's Fifth Symphony, we can notice that there are some of them that have counterparts in math, and we call them Geometric transformations. Musical transformations preserve structure in geometry. They must be done in such a way as to preserve at least a sense of structure of the original theme. With repeated hearings, we recognize the presence of shape of the themes on a subconscious level. First type of geometric transformation and their counterparts in music is what we call translation, and in music it is called transposition. In geometry, it is called shifting. A figure is picked up and moved to another location without any change in size or orientation. In music, the theme is shifted, for example, to the fifth below the original theme. Next up, we have reflection about a horizontal axis. In music, it is called inversion. Up and fifth and down a second into down a fifth and then up a second. This is an example in which we can see in Beethoven's Fifth Symphony. Another one is reflection about a vertical axis, and its counterpart in music is called retrogression. This is simply known as playing the notes backwards. Next, we have rotation about 180 degrees, or in music it is called retrograde inversion. The melody is rotated at 180 degrees. The rotation of melody will be composed of two previous ones, and the melody is upside down and backward. Next is dilation with scale factor greater than 1, and is known in music as augmentation. In geometry, it is called magnification, and in music, it is described as being twice as slowly or four times as slow as the original tempo. Next is dilation with a scale factor less than 1, or diminution. In geometry, it is called the- it is called magnification, but in music, it is twice as slowly or four times as slow. So as a common theme, we should now know that composers use structure-preserving transformations to create the balance of unity and variation to be aesthetically pleasing. We now proceed to another example. The Three Blind Mice is likened to translation in geometry. With the opening two bars of the songs, we notice that three notes are repeated consecutively whole step. We also know that Three Blind Mice is a round song and starts when a person or group sings, and after four bars, they sing another line in the song. The others follow the phrases until you can hear a pleasing auditory stimuli. Another example is Johannes Bach Crab Canon. Was popularly referred to as Crab Canon. Nowadays, it is referred to as a retrograde canon. Upon exposure to the sound, You may recognize patterns orally and instinctively determine them. Through visualization, you can follow the notes throughout the score and try to reverse the piece in the other direction. Bach created the canon such that it can be played simultaneously, backwards as well as forwards. The crab canon, as observed, is made of two complementary reversed musical lines.
Next, we're going to talk about mathematical forms and concepts in architecture. When we look at buildings, we see design, color, and structure. But what we don't know is that these are all based on various mathematical concepts that architects use to meet the needs of the client. Take, for example, the Integral House in Toronto, Canada. It was built for musician mathematician Dr. James Stewart. He wanted three things in his house: curves, glass, and a good performance space. The integral house got its name from the integral sign in calculus, which coincidentally is the same shape as the sound hole in a violin. When Dr. James Stewart incorporated curves, he wanted to make use of the volumetric curve, which is the volume shaped by curves rather than a line shaped like a curve on the ground. Take, for example, the performing spaces in his house. It was also Dr. James Stewart who said that calculus can be viewed as the mathematics of curves. Next, we have the head office of San Miguel Corporation. The inspiration for this is the Banawe rice terraces. Aside from Stairway to the Sky, other patterns found in the rice terraces are whorls, triangles, circles, and the like, which are the same patterns on hems and sleeves made by Ifugao women and worn as tattoos. Last but not the least, we have UP Baguio's own Teatro Amianan. Dubbed as a microtheater, Teatro Amianan is also an art space and gathering area. Its design centered on the creation of a new public space, and it used elements needed for the interior environment of the building, such as acoustics. The creators or the designers of Teatro Amianan wanted to incorporate timber to represent culture, as you can see in the photo, while at the same time maximizing space and enhancing the environment of the UPB campus. You can see math in maintaining these three that I have mentioned. They used mathematical concepts in working around terrain and vegetation, while making sure that acoustics are constant throughout the interior of Teatro Amianan.
So now we will talk about the math of dance. So dance is a movement usually set to music with an emerging structure and pattern. So sabi nila, hindi lang daw yung synchronous sound pattern ang bumubuo sa isang sayaw. There's usually an underlying mathematical idea realized in artistic form. And because of this, dance can be described as geometry in motion. Without geometry, dancers would not be able to synchronize and create shapes. Dr. Karl Schaffer, Eric Stern, and Scott Kim are all mathematicians, and the two of them are choreographers. They noticed that math and dance both deal with codified concepts. Spatial awareness is the ability to be aware of the objects around you as well as your position in space relation to them. Habang sumasayaw tayo, kadalasan we are counting the steps para maganda yung timing niya sa mismong music. So dance is also full of patterns na pwede nating tignan in a mathematical manner. Mr. Louis Hort is a known choreographer. Ito yung mga kadalasan niyang sinasabi sa mga students niya. A quarter of an inch makes a difference, that sort of exactitude that makes it professional. Yung phrase na quarter of an inch can be considered as a statement with a mathematical idea. So bawat galaw ng mga dancers sa stage ay napag-isipan. Lahat din ng galaw nila ay kalkulado. Measured out, not freewheeling, you only rolled over. Move like a spear in space, never lose the planal concept. Sabi nga kanina, bawat galaw nila ay kalkulado. There is a right way to do the dance steps. Hindi mo lang basta gagayahin yung steps, you also need to connect with your surroundings. These quotes are from a student of a national artist for dance, Leonor Orosa Gukinko. Ito daw yung mga natutunan niya sa kanyang mentor. When we raised our hands, every arm was exactly as if the same angle, though we were different heights. That precision had before so automatic, we would have angled our arms just so unfirmly even if we were all fast asleep. You do get bored doing the same thing, especially if you have to do it twice a day. Our movements were kept precise by what we call muscle memory. If you have noticed, when we are asked to do something with our body parts, we sometimes do it uniformly and precisely because our body is made just like that. Our movements were kept precise by what we call our muscle memory. If you keep moving your body the same way for many times, your muscles tend to remember the angle of how we wave our arms or the height of how we raised our knees. These are just a few examples that have almost the same definition in math and in dance. Direction. In dance, it is a line of movement made while moving in space, forward, backward, sideward, diagonal, upward, or a combination of these. Sa math naman, direction is yung direction ng vector quantities that have magnitudes and determined by angles. Level, as defined in dance, is the height of the dancer in relation to the floor. A dancer can be at a high level, medium level, or low level. For a two-dimensional plane, the point of references is the horizontal axis. A set of points can be located above this axis. Range naman yung tawag sa area na nakakover ng body habang sumasayaw or nag-move siya. And in math, it is the range of a function which can be visually determined from the graph's coverage. Next is the floor or space pattern. In dance, it is the path or design on floor or space that made while moving in space. In math, it is the shape of the graph of a function. Next, so there are four types of symmetry in mathematics: translation, reflection, rotation, and glide reflection or glide. Translation symmetry in dance happens when a dancer's body translates itself through space during movement. So dance itself is a physical translation. Reflection symmetry or mirror symmetry. Pag nanonood ka minsan ng mga nagsasayaw, yung mga dancers ay para lang silang reflection ng isa't isa dahil sa pare-pareho nilang mga galaw. Sa dance, may rotation. Sa math naman, may turning symmetry. May glide din na tinatawag sa dance which is considered as a combination of slide and mirror symmetry. So uh, yung matututunan mo dito is math is really everywhere since dance is full of patterns. And sa mathematics, patterns is very important din. Ayun.
Math and our indigenous weaving culture. According to a talk presented by Dr. Maria Louis Antoinette de las Peñas, mathematicians have already acknowledged the presence of math in artwork since the early 1900s. In this particular discussion, we will be focusing on the presence of math in our country's weaving culture. Our country has millions of indigenous peoples, from the highest towns of the Cordilleras to the southern Bay areas in Mindanao. These indigenous cultures produce a vast amount of diverse weave textiles. Sobrang yaman ng kultura ng Pilipinas dahil marami tayong indigenous community sa atin. Maraming kultura ang kilala sa kanilang paghahabi, kaya't marami rin tayong pwedeng maaral ng mga hinabing tela o weave textiles. Mahihinuha rin natin sa pamamagitan ng pagsasaliksik at masusing pagsusuri na kinakikitaan ng consistent mathematical concepts ang mga hinabing tela. Our ancestors and indigenous communities may have had mathematical instincts in crafting their artworks and material culture since time immemorial. Aside from our focus for this part, which is woven textiles, mathematical concepts are also seen in cultural ornaments, mats, accessories, wall decorations, and baskets. But for today, we will investigate how mathematical patterns are present and alive in these intricately weaved textiles. First, let me discuss the relevant concepts. Motif. This is the basic repeated pattern or element. Ito yung mga main element na inuulit-ulit sa paghahabi. Next is the okir, okil, or ukil. This is a folk motif, geometric and flowing. Isang uri ng motif na base sa leaves and vines. Madalas itong makita sa mga paghahabi ng mga Maranao. Our very own sablay has a woven okil. If I am not mistaken, this element right here is what they consider the sprouting plant, which represents the growth of knowledge. Just like in the mat of dance, our weaving culture also has 4 types of symmetries. First is the translation. This is when the motif is arranged in a given distance and direction along a line. Inuulit yung motif ng isang direksyon, dire-diretso. Next is reflection. When the motif is reflected along its line or reflection axis, it produces a mirror image. Basically, yung design ay nire-reflect para magkaroon ng mirror image. Next is rotation. This is when the motif is moved at angular intervals with respect to a fixed point. Niro-rotate yung design or motif at a constant angle habang may pinagbabasihan na fixed or central point. Last is the glide reflection. This is the combination of translation and reflection. Inuulit-ulit yung reflected design or motif ng dire-diretso. May 2 types pa ito. First is the frieze or strip pattern and the wallpaper pattern. Frieze pattern ang tawag kung ang pag-uulit ay tungo sa iisang direksyon. O sa bigger picture, pantay-pantay at iisang direksyon lang ang lahat ng element. Ang wallpaper pattern naman ang tawag kapag may dalawang direksyon na kinapupuntahan yung isang element. Here's an example. This is a pinlian blanket. Pinlian means divided or separated. This is a technique famously used by Itnegs of Abra and weavers from Ilocos. May malaking pagkakatulad ang kultura ng Abra at Ilocos. Their weaving technique perhaps is one of it. On this slide, we can see their motifs in translation symmetry. Sunod-sunod, isang direksyon. Next, for reflection, if we look into it further, we can see how these designs were reflected horizontally and vertically. The weavers created a pattern whereby they reflected the designs to be perfectly symmetrical. And then next, if we look closely again, each part of the motif seems to be rotated at 180-degree intervals. Each part is rotated equally and symmetrically. Lastly, the woven blanket is sorry. Here, we can see the shift in two directions ng design sa weave blanket. Lastly, the woven blanket is not entirely symmetrical since the weavers included symmetry breakers on the last two rows. Symmetry breaking is a concept in mathematics, basically when the symmetry is broken. These images of horses and humans dito sa dulong part, sa may laylayan, these were placed to indicate the end of the pattern. Here ends my discussion for our indigenous weaving culture.
In this last part of the discussion, we will talk about the connection between the principles of mathematics and our beloved poem. First of all, we must define what constitutes as a poem. What is poetry then? Scholars have varying explanations and viewpoints for this rather complex topic. But for class, it ought to be defined in the most encyclopedic. According to Britannica, poetry is a kind of literature that evokes a concentrated imaginative awareness of experience or a specific emotional response through language chosen and arranged for its meaning, sound, and rhythm. So a poem follows certain parameters along with the goal of conveying feeling. That is why it is said that poems have the right words and the right word. Filipinos are also known to be natural poets, experts on rhyme and reason. This can be observed in the various ethnic groups across the Philippines and their traditions such as the Tagalogs and their Balagtasan, the Ilocano Dalo, the Mindoro Ambahan, the Cebuano Balitaw, the Kapampangan Total, among many more others. But apart from that, it can also be seen in the contemporary spoken word poetry gatherings, which are gaining popularity. The American philosopher and psychologist William James wrote, "The union of the mathematician with the poet, fervor with measure of passion with correctness, this surely is the ideal." Poetry can be likened to mathematics with its use of numerical formulas. For example, types of poems, there are required number of syllables which define it. For example, sonnet is a poem consisting of 14 lines with 10 syllables. Seaplane is a verse of non-rhyming 5 lines. Meanwhile, a haiku is a poem that has 2 lines and 17 syllables overall, with specifically 5 syllables on its first line, 7 on the second, and 5 on the last. Evidently, not all poems are primarily concerned with rhyming, especially the Japanese haiku, which we will demonstrate in the next. Consider the 13 haikus written by Leslie Ann Garcia, Ana Jane Dolin, and Julie Ann Medrano of UP Los Baños. The first letters of the titles of the 13 haikus form the word combinatorics. Do you still remember the concept of Fibonacci numbers? Each number of the sequence is generated by adding the two previous ones, starting with 0 and 1. Nothing is impossible with a poem. You can write poems using the pattern that determines the terms in the sequence. This type of poem is called the fib. According to Joan Gray, a retired math professor who occasionally lectures in writing workshops, a limited form like the fib can possibly help novice poets who are having difficulty. For years of teaching math classes, she made use of poetry emotionally connect the students to the subject and view the study of it as a shared human experience. As mentioned earlier, in writing poetry and incorporating certain forms, you can either count words, the syllables, or both, depending on the type of poem. For the fib poem, you're also free to choose. Andrew Jackson counted birds when he used the 1-1-2-3 pattern for the following four-line piece. One person with courage, a majority. Oliver Wendell Holmes Jr. counted syllables in framing the following line piece in 1-1-2-3-5 pattern. Life is painting a picture, not doing a sum. For longer poems, a possible structure would be lines with number of words follow the 1-1-2-3-5 3-2-1-1 pattern. Consider this Fibonacci poem Stacking, written by Dr. Nat Friedman, who did postgraduate study on ergodic measure, preserving transformations on the unit interval. Stacking is a method for constructing transformations on the unit interval 0-1. Each extension begins with a set of ladders. These ladders are cut into subladders and stacked to get higher, thinner ladders, where each represents a subinterval and maps to the rung directly above. A sequence of such extensions completes. Did you notice how the mathematical structure deepened the poem's effect? You can see how the specific limitations allowed for the movement or delay of words in a series into later parts. In my course, the Language and Literature, we call this enjambment. This is when the poet chooses to abruptly cut a thought halfway through and move it over to another line without any punctuation. It can trick the reader, evoke a certain feeling, influence them to think about what comes next. Going back, Dr. Friedman received his PhD in 1964. He wrote the following autobiographical Fibonacci poem for Raphael Chacon, his thesis advisor at Brown University. I was very lucky. My thesis advisor was always willing to converse. He got me started on an interesting project that was appropriate for my level of understanding, and I almost solved completely. He showed me it was easy to complete. Thus, I had result one, then result two, and soon I finished. Aside from the 1-1-2-3-5-8-13, 8-3-5-2-1 format akin to reflection, you can also experiment with other progressions such as 1-1-2-3-5-8, 1-1-2-3-5-8. But besides the counting of syllables, stanzas, and lines, poems can also have unique shapes. Most of the time, we encounter poetry in the conventional rectangular shape, aligned to the left side or centered. However, there are also some instances wherein the shape of the poem is not exactly this uniform, and the shape of a poem is reflected in some way to its meaning. This is called visual poetry. Poet and mathematician Charles Dodger, more popularly known as Lewis Carroll, the author of Alice's Adventures in Wonderland, tells a short narrative about the tale of a mouse through a long, ale-shaped poem. When the poem is specifically delivered in the shape of its subject, this is then called a concrete poem under the earlier category. Mine is a long and a sad tale, said the mouse, turning to Alice and sighing. It is a long tale, certainly, said Alex, looking with wonder at the mouse's tail. But why do you call it sad? And she kept on puzzling about it while the mouse was speaking. So the idea of the tale was something like this. That was an excerpt, and that our discussion about the arts and humanities.